Okay, so starting off in this chapter, which is algebraic expressions, there are still a lot of things that you have already done in the terms before, which is term 2 and term 1, which you had already done algebraic expressions before. But now, what's going to be happening in this time when you do algebraic expressions is that there's you still need to know those terms, coefficients, constant terms, and all those concepts for this chapter that you had learned previously. But now the difference would be that it would be more difficult or a bit more trickier, if I could put it that way. Okay, so the first question here that we're going to look at is basically just testing whether you do remember some of these important terms of how many terms are there in an expression, right? And the expression that they are talking about is the one that is over here, where it's 5x squared plus 4 xy minus 3x to the power 3 minus 7, right? So what is meant by a term? Firstly, remember what a term means. It means it is a specific, or how do you identify a term? A term, how you identify it is by seeing whether or not it's separated by an addition or a subtraction. So in actual fact, if we have 1, 2, 3, 4 things which are separated by the operations of addition and subtraction, then we have 4 terms. Okay, so how many terms do we have in the expression? It's 4 terms. As you can see, it's 5x to the power 2, 4xy, 3x to the power 3 minus and 7, right? And then the next question is, what is the coefficient of x? Now they quite specifically told us what is the coefficient of x, right? Now they didn't literally tell us that they want the coefficient x squared or x cubed, but they just said the coefficient of x, and the only term that has x just as x is 4xy, right? So it is 4, right? And then you can also go on and say, what is the constant term, right? And the constant term here is just minus 7 or 7. And then what is the degree of the expression? Now, when they talk about the degree, they are actually looking for the highest exponent, right? And that would tell us the degree of that expression or polynomial, right? And so in this case, the highest expression, the degree of this expression is 3, right? So it's 3. So the degree of this expression is 3 because it has to the power 3 there. And as I said, when they're asking you about the degree, they really mean they're talking about the highest exponents, right? And then the types of questions again that you'll probably see in this chapter is to simplify the following expressions. So the ones that are in red are the ones that I have done for you, and the other ones I'd like for you to try them out. So you'll probably have to stop the video now and try them out. So the first one, quite simple, quite straightforward. It's a, which is 3x, all multiplying 4x minus 5. And we all know that, okay, what we do here, we just multiply 3x inside. And then when we multiply 3x, we find this final solution, which is 12x squared minus 15x. And then again, with D, you have 2 brackets now where it's 3x minus 2. And then in the second bracket, you have 9x squared plus 6x plus 4. Now this does resemble a type of factorization, if you have done it yet, is cubic factorization. But let's see. Now, when we multiply this in, it means that we're going to take 3x and multiply it with all the other terms in the second bracket, and we'll take minus 2 and multiply it with all the other terms in the second bracket, right? And this is the expansion that we get. And then once we find the expansion, we actually find that 18x squared will cancel with minus 18, and 12x will cancel with minus x squared, x, right? And then you'll only be left with 27 to the cube minus 8. But notice something here, 27, that is actually 3 to the power 3. 8 is actually 2 to the power 3. And you have x to the power 3. And that's why we call it cubic factorization. If you used cubic factorization, then this would be its factorized form, where it's 3x minus 2, 9x squared plus 6x plus 4. Okay. And then we have another one where it's f, where we have 8a plus 7b to the power 2. And what happens is that, okay, this square here basically means that we have 8a plus 7b multiplying itself as 8a plus 7b. And so from here, then you multiply in for both, and then you'd find your answer to be 64a plus 112ab plus 49b squared. And that would be your solution for that one. And then we have I, which I is a bit more interesting in the sense that you have a bracket, right? You have a bracket for 15ab squared plus 3a squared plus c to the power 3 minus 27abc, right? All divided by 3ab, right? So what's actually happening here? Now, when we have a division, remember division, we can also rewrite as a fraction, right? And we can rewrite it as a fraction where we have everything that was in the bracket on top as the numerator and then at the bottom as the denominator. And then once we have done that, then we can actually divide this single term. Now, why can this work? If we had plus 1 like this, then we could not take 3ab plus 1 and divide it for each individual one, right? But because at the bottom the numerator is actually a single term, we can actually take 3ab and divide it by 15ab squared. Now, what is 15 divided by 3? 15 divided by 3 is 5. But then a divided by a is just 1, so it cancels out. And b squared divided by b, when you think of the exponent rules, that would mean that you have b squared minus 1, which is basically just saying it's it's b to the power 1 subtracting the 2 at b, right? And that's how you'd find that answer. And you'd do the same thing, and then you'd find that your answer is 5b plus ac cubed minus 9c. Okay, so again, please try these problems out. Now, here's a factorization again. Now, in this case, in this questions here, you'd find that they don't actually tell us what type of factorization are we supposed to use, whether it's common factor factorization, grouping, or quadratic factorization, cubic difference of two squares. They have not told us. So here, it's about you being able to identify the type of factorization you need to do. So in this case, I will start off with the f. So with f, it says 108 x squared y squared minus 192 a squared, right? So in this case, I can actually identify that, okay, 108 and 192, I do not know any number that is a square of it, right? I don't know the squares of 108 and 192, but what I do know is that both of them share 12 as a multiple, like as a factor, right? So I actually take out 12, which is common factor factorization. So I've just taken out the common factor, which is 12, and then I'm left with 9x squared y squared minus 16a squared. But now I do also notice something else. What do I notice is that the 9 there can be written as 3 to the power 2, which is a square. And also 16 can be written as 4 to the power 2, which is also a square. So now you actually have a difference of two squares, and if you know what a difference of two squares is, then you know that, then you're just going to write 3xy minus 4a, 3xy plus 4a, or in the other way where you say 3xy plus 4a and 3xy minus 4a. The order of these two brackets does not matter, but what does matter is that it has to be, you have to have one bracket that has a negative and the other bracket that has a positive. And then the next one here, if you look at k, again, you do not find a very straightforward factorization. Henceforth, the first thing I used was a common factorization, where I found that 7m squared of n, when I take it out, it leaves us with 6n minus 12m plus 3m squared and n to the power 4. And then you do also see that, okay, no man, in actual fact, inside the brackets, I can see that I still have a common factor, which is 3. So if I take out 3, that means it's 2 times 3, 3 times 7, 3 times 7, which is 27. And then we just take out 3, and then we are left with the final answer, which is that one there. Okay. And then we have here a very interesting one of where it says 36 xyz plus 19 abc minus 12 bdf, right? Now with this one here, what you should notice is that 36, 19, and 12 do not have a common factor, right? And then when you look at xyz, there is nothing common to ABC, right? But then with ABC, there is something common between B, D, F, which is B, right? So then you take out B, and then you'll be left with 19AC minus 12 DF, right? And you'd leave the fun part alone. And that would be your answer, because there isn't anything else that you could have factorized meaningfully and found a different type of factorization, okay? And then here we have 3ax squared plus 66ax plus 360a, right? And obviously the first thing that you can notice is that all of them have a common factor of 3a. And so you take out 3a, you're left with x squared plus 22x plus 12, or 120. So now you have inside a quadratic expression. And a quadratic expression, how do we figure out in quadratic expression? We look at our 120 and we say, what are the two numbers that we can multiply together to give us 120, which is 10 and 12? But then we can also add together, that would give us 22, right? So we do know that 10 times 12 gives us 120, but also 10 plus 12 does give us 22. And therefore, that's why we have our factors to be x plus 10 and x plus 12, and we have 3a at the outside, right? And then lastly, this one, a, b, a, d, e, f, and h, we're going to look through quite quickly. Now here you'll be looking at expressions, but now the whole point about these types of expressions is that you just need to apply your factorization first and simplify and cancel out the things that need to be cancelled out, right? So the first one here, you have x squared minus 16 and x squared plus 6x plus 8, right? Now the numerator, which is x squared minus 16, is a difference of two squares. So you have x minus 4 and x plus 4, and then at the bottom you have x plus 4 and x plus 2, because x squared plus 6x plus 8 is actually a quadratic. It's a quadratic function, so you look for two numbers that you can multiply together to give you 8, but also when you add together should give you 6, right? So we found the factors, but now at the bottom and top, what you find is that x plus 4 is the same as x plus 4 at the bottom. And remember, it's just the same as saying it's 2 over 2, and 2 over 2 just cancels each other out, and we know that that just cancels. And so you'll be left with x minus 4 and x minus 2, right? And then the others as well, I would like for you to really try and look at these types of calculations. Yeah, with this one here, I guess the key part that I need to mention is that, one, because it's division and they have fractions, you need to not forget that you'll have to swap the denominator and the numerator. But what's swapping is not everything, it's just the divisor, the thing that is divising. And I mean, what do I mean by divisor? When I say it's 3 divided by 2, I mean, what is the divisor there? That's 2. And so whatever the divisor is, that's where we change. And then you also can try and look at this one on your own, and all of the rest. So other than that, I really hope that these videos are helpful, and I will see you next time.